Okay, and since we have a phase change, we have to use Q equals mH. And again, we're melting, so we're going to use heat of fusion, because that's what we use when we go between solid and liquid. We know our mass is 25 grams, so we can calculate Q is equal to 25 grams times heat of fusion, which is 334 joules per gram. When we multiply those together, we get 8,350 joules. Then we need to look at our significant figures. Again, constants we don't use, only things that we measured, and so that's 25. So 25 has two significant figures, so our answer needs to have 2. This one currently has 1, 2, 3, and so we need to round that to just 2. So what's the second significant digit? 1, 2 is a 3. We look to the right. Can I round it up? Yes, I can. And so that would become 8,400 joules. Now, if we were to do problems, and we are going to do problems, where we're going to combine these ideas. So let's say we were going to go from solid at -5 degrees. We go from ice at -5 degrees. This problem's not in your packet. So we're going to go from -5 degrees up to liquid at 50 degrees. And so we would have to determine the amount of heat it takes to do this part, and then this part, and then add them all together. We'll be looking at more of those later. Alright, so let's look at calorimetry problems. Right, calorimetry is what we use when we're trying to determine the specific heat or amount of heat that's transferred. Alright, so we have a piece of metal which has a mass of 14.8 grams, and it decreases the temperature from 109 degrees Celsius to 30 degrees Celsius when we place it in 25 grams of water at 25 degrees. So what's the specific heat of this metal? Well, there's so much data in these that we need to organize that a little better. So we have Q of the metal that we would calculate by doing mc delta T, and we have Q of the water that we would calculate by doing knowing the mc delta T as well. And so what's the mass of the metal? 14.68 grams. What's the mass of water? 25 grams. What's the specific heat of the metal? Well, that we don't know, so we'll call that X. And what's the specific heat of water? 4.18 joules per gram degree Celsius. And then what's the change in temperature of the water? Well, the change in temperature of the metal first, we have from 109 to 130. So again, delta T for the metal will be final minus initial, 30 minus 109 would be -79 degrees Celsius. And then the change temperature of the water would be the final temperature, which is also 30 minus 25. And so that would be a positive 5-degree change. Right? And so since we know that the metal and the water transfer equal amount of heat, we know those two things have to be equal to each other. And so we have set up our equation that Q for the metal will be equal to Q for the water, except that the metal is going to lose heat energy and the water is going to gain, so the metal is going to have a negative. So we'll have a negative mc delta T for the metal equals to a positive mc delta T for the water. And so then we will calculate what C is. So we multiply the right side and divide by the things on the left side. And we get that the specific heat of the metal is 0.45. Now I've kept only two significant figures because that's the least number I had. Here was 2, and the temperature here was 3, and that one was 4. So I needed, your mass was 4. So we just kept two significant figures. Now the units will be joules per gram degree Celsius. The second part of the question tells us to identify the metal. So we're going to identify the metal. The specific heat is 0.45. We look on our reference table and we find one that's close to 0.45. And the closest one to 0.45 is iron. And so this would be iron. Alright, so I want you to do the practice problem on your own, and we'll discuss that in class tomorrow.